Okay, so hi everyone, and thank you for joining the L3VPN MPLS session. So in this session, we will learn about what is a layer 3 VPN, and also we'll do a lab on this. Okay. So before we start, let us discuss on a very simple question first. The question is, how does a company connect all of its branch offices together? For example, I have an office in Chennai, second office in Bangalore, Hyderabad, Delhi. All these offices need to communicate as if they are part of one single private network. So you might think, okay, Vishnu, I can simply connect them using an internet. By connecting them in internet, this can be termed as one single office and the communication is possible. But it is not secure. Connecting all my office using internet is not a secure way of connecting them, because the internet is a public network. It's completely a untrusted zone. So they approach a service provider like Airtel, Jio, Tata Communications or BSNL, and the service provider like this, they can give them a private VPN for that customer. Now today we'll understand how Cisco MPLS Layer 3 VPN makes it possible. So you will learn about understanding an L3 VPN, understanding what is a CE router, PE router and P router. We will configure an MPLS Layer 3 VPN lab also. We will verify everything is working perfectly, and then I'll give you some common troubleshooting problem. See, notice this title, okay? Title is MPLS Layer 3 VPN. So don't worry too much about MPLS, because MPLS, we should have already finished the class about MPLS and all. And Layer 3 VPN is what? Something new we will study. See, imagine you have a company called ABC. They have offices in Chennai and Bangalore. The employee from Chennai and Bangalore, they need to exchange file server informations, HR application, database, right? Instead of building their own expensive WAN, they can go with a VPN service from a service provider. Okay. So what is VPN? VPN is a virtual private network, meaning whenever you want to communicate to private LAN over a public internet, that too securely, use VPN. Okay. Now you got understanding of what is the use case of your Layer 3 VPN. Now we'll talk about what is MPLS Layer 3 VPN. See, now that we know the companies need private connectivity, let's understand what exactly an MPLS Layer 3 VPN is. See, first of all, don't worry about this long name, because I'll break them into small pieces first. So when I say Layer 3, when I say MPLS, means in the backend we are running MPLS network. Layer 3 means we are going to do IP routing. See, we know something called Layer 2 VPN. Layer 2 VPN is Layer 2. It gives switching. This one is giving IP routing. VPN means virtual private network. MPLS is the technology used by the ISP to send your traffic. So in simple term, Layer 3 VPN allows multiple companies use same service provider network while keeping each company's network completely separate. So let me give you a simple analogy. Imagine this as a building a big apartment. Okay. The apartment is having hundreds of families. Everyone uses same entrance, same lift, same parking area. But does a family have access to other family's house? No. Each family will have its own key. Even though everyone uses same building, every house is a private. Same way, internet is like common way, like lift, your parking area, entrance. That's like your internet. Once the traffic comes in, depending on where the traffic need to go, it will go to a individual house. And between houses also, they cannot talk directly. If they wish, they can talk, but normally the customers will be separate network. Okay. Let's read the definition. An MPLS Layer 3 VPN uses MP-BGP, multi-protocol BGP, to advertise customers' IPv4 routes across a provider's MPLS core, keeping each customer's routing table logically separate through something called VRF, Virtual Routing and Forwarding. Prerequisite to understand this concept is MPLS topic and VRF concepts. In our class, we have finished everything already. So multiple customers share same physical network, but each sees only its own routes. Let's understand this. See, it says an MPLS layer 3 VPN uses MP-BGP to advertise customer routes. So don't worry about MP-BGP today. We'll configure it later on. The important idea is customer routes are exchanged between the provider edge router. Here you can see. This is provider edge router. PE router is a router that connects to a customer edge router like this. So PE router is a router that connects to the customer edge router. Behind PE, we are having P router, provider router. Okay. The important idea is customer routes are exchanged between provider edge router. Now notice another key called VRF. VRF. Remember this word? We might have studied about VRF, virtual routing and forwarding. Simply it is used to create separate routing table for each and every customers. Instead of one routing table, I will have VRF A for customer A, VRF B for customer B, VRF C for customer C. Because my customer might use same logical IP address, right? Maybe this is a customer 1. I have one more customer called customer 2. Both of them internally they will say I'm using 10.001. So when both of them are using 10.001, traffic is coming in P router. Here I need to divide them into two different places, right? That's why we are using VRF, virtual routing and forwarding. See why service providers use L3 VPN? Left hand side, see it. So instead of building a separate network, one backbone support thousands of customers, very easy to expand also. And here we can have any to any connectivity. Suppose a company office has offices in Chennai, Bangalore, Hyderabad, and Delhi. Every office can communicate with every other office. So you no need to create lease lines and all between every pair of branches and all, not required. Okay. So let's understand this. Customer A uses 192.168.1.0/24. Customer B, imagine I have one more customer. Even customer B is also using same IP. Normally, this will create a conflict in PE router, right? Because in routers, every interface has to be part of different network. So, but in L3 VPN, each customer has separate VRF. So both customer can use same IP range without any kind of IP conflicts. Now you guys tell me in Zoom chat, yes or no, can two different company use same IP address normally? Like in these interfaces, can I configure 192.168.1.1? Here also same IP ending with 2. Can I configure? Yes or no? Okay. The answer is, it's okay, fine. The answer is no. Because of the IP conflict, they cannot configure. Apo, we'll use VRF so that we can configure also. Okay. So why we have to use this? We can avoid overlapping IPs and all. It's secure and logical because I'm going to use VRF and route distinguisher between them. So it's secure and logical. The same time, it's lower cost compared to a dedicated lease lines. So let's understand the terms used here. First major term is customer A. So customer A is my, sorry. We'll understand the components used in layer 3 VPN technology. Say I have customer LAN A and I have CE router. In customer edge router is for customer only. The end router of a customer which connects to my ISP router is called customer edge router. It runs IGPN static route pointing towards ISP's PE router. In PE1, we are having VRF and MP-BGP configuration. After this, I'm having MPLS network. It's a provider core router. Again, MPLS network. Go into PE2 router, provider edge 2 router. Then I'm having CE router, CE2 and customer B. CE means customer edge. The customer's endpoint router, which is connected to the ISP. See, there is no MPLS, nothing fancy about CE. It's a normal router. P is what holds all VRF, MP, BGP, everything. P means core router, VRF routing and forwarding. Route distinguisher. See, route distinguisher and route target. Very, very important interview question also. Understand very carefully. Route distinguisher is a 64-bit value and normally represented like a AS number colon some number 100 colon 1 makes overlapping IPv4 route globally unique across MP-BGP locally significant. Meaning, see in PE router we are dividing them or we are segregating the IPs based on VRF, right? What if they come here in provider routers? I need to divide the traffic here also now. So to make it unique, we'll add in layer 3 VPN, we'll add on top of IP address route distinguisher also. So that this route distinguisher from one customer is maybe 100 colon 1. Second customer route distinguisher is 200 colon 1. So when the same IP address traffic is flowing, as we're adding a route distinguisher in that, the routes will be distinguished here. Route target works on the edge devices. What are the IPs I should import and what IPs I should export? It's not like all traffic from customer router should go through MP-BGP setup, right? So in route target, I can define what are the routes I should be importing or exporting inside VPN. MP-BGP, nothing but it's a VPN v4 prefixes. See, when you're adding your IP address plus route distinguisher, right? To make it unique in the path, route distinguisher plus your IP address. This entire setup is called VPN v4. Okay. So VPN v4 means what? Your IP plus that route distinguisher is termed as VPN v4 label or VPN v4. It labels between PE to PE router. So when the traffic is going on, right, I'm simply adding, imagine IP is coming here. So customer 1, customer 2 IP is coming here. In this path, na, same IP, maybe 10.001 will go colon 100 colon 2. Same IP will go here also 10.001 colon 100 colon, sorry, 200 colon 1. So now it's called VPN v4. VPN v4 means IP address plus your RD, route distinguisher. Remember the formula, L3VPN is not a single protocol like OSPF BGP. L3VPN is made up of VRF plus route distinguisher plus route target, MP-BGP and MPLS. Only if you are aware of all these topics, you can work on L3VPN. That's why this topic always learnt at the end of your course, because it includes everything. Now let's understand how a packet travels through. Now here we have LAN A to LAN B. I want you guys to draw this diagram first and read this once. I'll give like 2 minutes of time. Read this value 1, 2, 3, 4 now. Draw the diagram. Okay. Now we'll understand how the packet travels through L3VPN setup. Remember this, your L3VPN starts from here, ends here. C, you don't know what is MPLS. C, you don't know anything. Just a normal router, okay? This is also normal router. Whatever configuration is there, only on PE router, P router and PE you have to do. First of all, from LAN A, imagine there's an IP address 192.168.1.10. Host is sending a normal IPv4 traffic to its gateway called CE1. No label, no VPN awareness, nothing. A plain IP traffic from CE1 to PE1. Because in CE1 I have configured default route pointing towards PE1, it sends to PE1 as a normal IP traffic. Now in PE1 I'm having MPLS, right? Now PE1 will add two labels, okay? One will be outer label, one is inner label. Inner label is VPN label, outer label is your normal IGP label. So label goes like this. Imagine here my label is 10, label is 20, label is 30. My VPN label is 11, VPN label is 12. So data is here. Data on top of this, I am having VPN label 11, 10. This traffic goes here. Your VPN label will be safe only. It won't change. 20, VPN label is 11. Here data. When it goes here, now VPN label, normal label 30, VPN label 11, data. In this, he will remove this label. Inside here only, VPN label will be seen. See, VPN label is an inner label. Only outer label will keep on changing or swapping in MPLS setup. Inner label will be seen only at the PE2 router. We will remove VPN label also, and here it will be sent as normal IP traffic. Okay. So in PE1, we are pushing two label. One is IGP label, second is called inner VPN label. In P, we are going to swap the outer label, nothing but IGP label will be swapped. It goes to PE2, POP is happening. POP means removing. So here we will remove both the label and we will look into the VRF, right VRF table. We'll set into VRF FIP table And based on that, normal IP traffic will come out here. Then PE2 to CE2 to LAN, the reverse traffic. Same way it's gonna go. See, two label do all the work. Outer says how to get there and each individual path is used. Inner says which VRF to hand it to. VPN label tells on PE2 which VRF table I need to give data because I might have multiple customers. Each customer has one VRF. That's why. Now we're going to go with the lab topology. Here you can see I have same customer here. Route distinguisher I'm using 100:1. Normally this first 100 is going to your AS number. This AS number. Mostly use that. Route target is also same. AS of this IBGP is 65,000. I'm using OSPF area 0. MPLS LDP will be configured from P1 to P2, P2. Don't get scared about diagram and all. Only in PE1 router and P router will configure. P router almost same lab as PE1 configuration. Okay. C to PE, I'll use static routing in this lab and I will do ping test of this IP from LAN 1. See, simple firewall lab. I'm going to use OSPF, MPLS here and one VRF on each PE. That's it. So here we'll form IBGP VPN v4 session also between PE1 to PE2 loopback IP 111123333. Okay. Let's. Here is the IP address. If you are possible means we can draw this diagram on a notebook. Then I'll show you the IP address also. You can write the IP address also. It's a big lab, so take your time and draw the diagram, guys. Here is the IP I'm going to use. So configuration anyways we are having. So let's go with the lab. For lab, I'm going to use GNS3. Let's use GNS3. Okay. So let's go with the MPLS lab. L3VPN lab. So we'll take one C router, P router, P router, then again a P router and another C router. So I'll be using normal IP addresses. Let's do that. 0/0, 1/0, 0/0, 1/0, 0, 1/0, 0/0, 1/0. Okay. This is my R1 is my CE router, R2, R3, R4, they are from ISP side. This is my provider edge router, provider edge router. Let me write these things down now. Okay. So CE, this is P, this is P router. There is also a P router. There is also a C router. Here I am going to use loopback 0, 1.1.1.1. Here loopback 0, sorry, 2222, loopback 0, 3333, loopback 0, 4444. Here also loopback 0, 555. Here I'm going to use 12.001/8 IP. Here 12.002/8 IP. 23.001/8. Here 23.002 slash 8. 34.001/8. 34.002/8. 45.001/8. 45.002/8. This will be the lab topology. Let's turn it on. First, I'll configure R1 router. Interface loopback 0. Interface. No. The same way we'll be configuring all the IPs one by one. I already have this, so let me just copy paste all my IP address first of all. 0, 12.0.0.2, no shutdown, just to verification the ping. Ping is working. Okay. So same way I'll configure R3. You guys know about the R3's IP address. Normally I have typed everything on my notepad also, so that I can easily copy paste the IP address and all. See, keeping all these configuration notepad actually is going to save a lot of time because you will not do any wrong configuration if you already have them in the notepad part. Next, R4. Okay. Last will be R5, CE router. Okay. So now we have enabled basic IP configuration everywhere, starting from your R1, R2, R3, R4, R5. Now we will start with the R2 guys, R2 to R5. So first of all, in step 2, in R2 we'll configure OSPF. Okay, configure terminal, router OSPF1. Router ID is network 2222.0.0.0.0 area 0. Network 23.0.0.0.0.255.255.255 area 0. Same way, we'll configure OSPF on R2, R3 as well as R4. R2 to R4 reachability should be there. Okay. So for that sake, I'll leave R5. R5 is a CE router. Nothing will do there. R3 will do OSPF. Okay. So now you can see R3 I've configured OSPF1, router ID, network for R3 and both the interface network I have done. Now we'll go with R4. R4 is here. No shutdown. Okay. In R4 again. Now we'll verify. In between R4 I'll go R3 I'll verify. Because R3 will show both neighborship, right? Show IP OSPF. It's in two-way state. Wait for some time. Both of them should go to full state. Yeah. Now they are in extract state. Let's wait for some more time. We'll go to full state. One is already full. This is R2, R3. This is R4. This is R3. Now good. Both are up. Now we'll go to R2 and check show IP route. I should be able to see 2 IP address, 3 IP address as well as 4 IP address. But 4 I'm not seeing for some reason. Now it is showing 4 also. Now we are good with it. Now on R4 also we are able to see everything. Now your OSPF step number 2 is finished. Okay. I will write these things down here. Step number 1 is IP address configuration. Step number 2 is OSPF on PE, P and PE router. Nothing but your R2, R3 and R4 router. Now step number 3, we will enable MPLS and LDP. Very simple command only, right? On R2, R3, R4, we can easily enable it. Let's go to R2, R3, R4, enable MPLS. Configure terminal, MPLS, MPLS, label, protocol, LDP. Go inside interface FA0/0. Listen to me very carefully. On WAN facing interface only will enable MPLS. Let me just draw this diagram. Normal. Normal time. Just a minute. Wait. This is my WAN facing network places. Okay. Normal. So only on FA0/0, FA1/0, FA0/0, MPLS will be enabled. Okay. So let's come back here. Let's go to R3. Here is R3. Leave R1 that side. R1 not required as of now. In R3, enable same command. MPLS label protocol LDP interface FA0/0 MPLS IP. Very simple command, enable MPLS and all. 1/0 MPLS IP. Same way this router also. MPLS label protocol LDP interface FA1/0 MPLS IP. Please remember, on LAN facing interface, we will not enable any MPLS and all. Okay. MPLS IP. Now I'll verify MPLS. We can verify MPLS using the command show MPLS interfaces to check whether my interface is enabled with MPLS or not. We can check LDP also. Show MPLS LDP discovery. I can discover my neighbor. Yes. I can even check MPLS route, MPLS forwarding table. Show MPLS forwarding table. It should show for which IP I am doing pop, for which IP I am push or swap. Like that you can see. So MPLS is up now. So next, first we have done IP address, step 1, OSPF, MPLS. Now we'll go with step number 4. Step number 4 is create VRF. VRF. Okay. Now we have to create VRF on P2, R2 and R4, PE1 and PE2 routers. Let's create VRF R2. Configure terminal, IP VRF, customer A, RD 100:1, route target, export 100:1. This is different, this is different, even though they look like same. Route target, import. So whatever the neighbor is exporting, I will import everything inside customer VRF A. Whatever I'm exporting, other side I'll import. Okay. The command looks almost same. If I copy for R4, right? See the R4 command. That looks almost same. IP VRF, customer A, RD is this. Whatever this side I'm exporting, this side I'm importing. This export number and this other side import number should be same. This export and this side import should be same. Now I can verify VRF also. Show IP VRF. I can say VRF A. Good. Now, as step number 5, assigning customers interface into VRF. See, very important. After applying IP VRF forwarding, right? IP address is removed automatically. See, if I go inside the interface FA1/0, if I say IP VRF forwarding for customer A, see, removed IP address. So we have to reconfigure IP again. It's a normal behavior. Whenever you call VRF inside an IP address, right? Automatically, the VRF inside one router, right? Router's interface, automatically IP will be lost. So we have to reconfigure that. So that's why we are reconfiguring it. So normal behavior. Okay. Now I can verify my VRF interface. Show IP VRF interface. My VRF interface is FA1/0. I'm customer A. Protocol is up. Now finally we can go with our step number 6. Step number 5 is what? Step number 5, configure VRF and call interfaces under VRF. Now step 6. Now moving towards more important step. Configuring MP-BGP, multi-protocol BGP. Now MP-BGP will configure mainly on R2 and R4. Okay. Let's configure it. Configure terminal. Router BGP 65,000. Neighbor is 4444. Sorry. Remote AS is also 65,000. Neighbor is 4444. Update source loopback 0. Then I'll go address family. Very important. And now I'm enabling address family for VPN v4 routes. For neighbor 444, activate VPN v4 neighborship. And also for sending out route distinguisher, right? I told you route distinguisher is what is going to make my route unique. If you want to send anything apart from normal BGP packets, I want to send route distinguisher. Normally, route distinguisher is sent under community field. So I'm enabling to extend that community value also for that neighbor alone. Now I'll exit. Now address family IPv4 VRF for customer A, redistribute all connected routes. That's it. So let me just grab same command and I can rewrite for R4. Just a minute. I'll use my Sublime text. If you want to take a screenshot also, I'll give time now. Okay. So R2, which is P1, this is what we have. Configured. Here you can see what I have configured. Now on R4, which is P2, will configure same thing only some things will change. Like instead of this 4444, for R4, 2 is neighbor, right? 2222. I think only one IP I need to change. That's why I always tell to use Notepad. It's easy to rewrite the command. I also will not do any mistakes at all. Everything is same. Now I can copy everything, go to R4 and simply paste it. Good. Now we have to verify this, whether MP-BGP is working or not. Let's go to R2, show IP-BGP VPN v4 all summary. Now see, now for VPN v4, this is up. It says established or it says 0 prefix, meaning we are good with it. Now to verify VPN route, the command is show IP-BGP VPN v4 all. Here you can see the route. I am seeing 12.00 route. Now I can check my customer's IP also. Show verify VRF routing table. Show IP route VRF customer A. Now I can learn 12 series IP address. Okay. Now so far it is good. We have enabled the VPN v4 itself. Okay. Now we'll configure the CE router with static routing. Very, very important. Because I need to have establishment, right, between R1 to R5. So my step number 7 comes. Here I need to configure static in CE routers. I have hidden my CE routers here. R1 is here and R2, R5 is here. Okay, that's R1, this is R5. First, I will write down the command R1. What I will configure? Configure terminal, router OSPF 10, router ID, network, This is for R1 router, okay? So I'll simply copy and then I'm going to paste it here, R1. Done. Same way I'll configure R2 also. I can just no R2. I mean the other R5, another C router. R5. What will change now? Only the IP will change, nothing else. 5555. Here again. Here again 45. That's it. Now go to this router R4 and paste. Good. Now we have configured OSPF in that side. Now we'll go with step number 8. This will be configuring P routers for customer OSPF. So in R2, which is P1 and R4P, I need to configure OSPF this side also, right? Then only the OSPF neighborship will form, right? I have OSPF inside my network, but this side I need to configure OSPF. See, VRF to OSPF configuration, I have already taught you guys how to enable OSPF inside VRF inside OSPF. So R2, which is my PE1 router, conf router OSPF 10, this is normal. Then VRF customer A. Then router ID is, for this I'm giving different router ID. Okay. Network 12.0.0.0 area 0. Then I'm going to redistribute now. Redistribute BGP routes with all subnetworks also. This I have to do in PE1. PE1. PE1 thing but my R2. Leave this guy. Where is R2? This is R5. This is R4. R2 should be here. R2 and R4 is what I am more interested in. So let's redistribute OSPF into BGP. Same command from R4 also. I copy to notepad. Now I can go to R1 and verify my OSPF neighborship first. R1, this is R1. Show IP OSPF neighbor. Neighbor is up. So we are good about it. Now I can check show IP route, VRF, customer A. I mean, sorry, in R1. In R1, there is no VRF and all. We have to do this in R2 or R4 P routers. R2 or R4. Where is R2? Here is R2. Now we can see the VRF table. Okay. I can even verify it on P router. The VPN V4 routes. Show IP BGP VPN V4 routes. See now I can see 55551111. Before it was not like this. Okay. Now finally I can go to R1 and try to ping R5 IP address. Ping 5.5.5.5. So I can go to R1 router and try to ping the loopback IP of R5. Now the ping is working. Now if I verify the trace path, trace route to 5555, you can see trace is showing right after traffic path. R1 to R2 to R3 to R4 like that. So all traffic is going via your P router to P router, P to another P router, then going to R5. This is all about your MP-BGP of layer 3 VPN setup configuration. The entire configuration with the diagram, you can find them in the description also. I mean, in your WhatsApp group also, I'll put it. Now, if you guys have any questions, please ask me in chat. Thank you.